हेलो एवरीवन, इन्फिनिटी मैथ में आपका स्वागत है। दिस इज़ डॉक्टर रुचिरा चौधरी एंड टुडे वी विल गोइंग टू लर्न अबाउट रैंक ऑफ ए मैट्रिक्स। मैट्रिक्स का जो बेसिक कॉन्सेप्ट्स है वो मैं पहले की वीडियो में दे चुकी हूँ। इफ़ यू हैव नॉट सीन माय फर्स्ट वीडियो, द लिंक विल बी गिवन इन द डिस्क्रिप्शन बॉक्स। इस वीडियो इंजीनियरिंग और बीएससी स्टूडेंट्स के लिए हेल्पफुल होगा। सो लेट्स स्टार्ट। बिफोर गोइंग टू द डेफिनेशन वी हैव टू लर्न अबाउट one thing, that is minor. How can we find minor of an element? Minor of an element is the determinantal form of the remaining matrix after excluding the row of column containing that particular element. If we want to find the minor of A1, we will have to do two steps. At first we will have to exclude first row and first column, and then we will have to write down the remaining matrix in determinantal form, that is B2 C2 B3 C3. Similarly, if we want to find the minor of the element B1, at first we will have to exclude the first row and second column. Then we will have to, because B1 is in the position of first row and second column, and then we will have to write down the remaining matrix in determinantal form and find out the determinantal value of the remaining matrix, that is A2 C3 minus A C2 A3. Now I am coming to the definition of rank of a matrix. Rank of a matrix is defined to be the greatest positive integer R such that the matrix A has at least one non-zero minor of order R. I am giving you an example to clear our conception. Suppose A is a matrix like this: 1 0 3 4 minus 1 5 2 0 6, and we will have to find out the rank of this matrix A. Now at first we will have to start with the greatest order minor of A. Now what is the greatest order minor of A? The greatest order minor of A is the determinant of the matrix A itself. So we will have to start with the determinantal value of A. Det A. If this is non-zero, then rank of the matrix A will be 3, because its order is 3 by 3. There are 3 rows and 3 columns. And if this is 0, then we will have to go to the next step, that is we will have to find out the second order minor, because remember these two terms, greatest positive integer and at least one non-zero minor. So if determinant of A equals to 0, then we will have to find out second order non-zero minor. So here if you calculate this value, determinant of A will be 0. So next step is, our next step is to find out the second order minor. 1 0 4 minus 1, this one is a second order minor of A. Next 0 3 minus 1 5, this is also a second order minor of A. Next 4 minus 1 2 0, etc., etc. Many others are there. Now if any one of these has a non-zero value, then rank of A will be 2, and if all the minors have 0, then rank of A will be 1, because we will have to find out non-zero minor. So if at least there is at least one non-zero minor of order 2, then rank of A will be 2, and if all the minor are 0, then rank of A will be 1. So here evaluate first the second order minor. This value is 1 into minus 1 minus 0, that is minus 1. Determinantal value of this matrix is minus 1. So the rank of A equals to 2. Now this method of finding the rank of a matrix is too much laborious and time taking. So we need some easier method to find the rank of a matrix. So we will use some transformation on a matrix, and this is called elementary operation on a matrix. Now there are three types of elementary operation on a matrix. First type is interchange of any two rows or columns of A, which is denoted by R, I, J. Suppose this is a matrix A1, B1, C1, A2, B2, C2 and A3, B3, C3. So if we use R1, 2 means we are interchanging the first and second row of the matrix, that is A2, B2, C2, A1, B1, C1, A3, B3, C3. So this matrix will be transformed into this matrix. So our next operation is multiplication of a row or column by a non-zero scalar C in F. That is, you are multiplying any row of the matrix by a non-zero scalar C, which is denoted by R, I, C or CRI. Means you are multiplying the ith row of the matrix by the non-zero scalar C. Suppose this is a matrix A1, B1, C1, A2, B2, C2 and A3, B3, C3, and I am operating on this R3, 5 or 5 R3. Means I am multiplying the third row of the matrix by the non-zero scalar 5. That is, the matrix will be transformed into this matrix A1, B1, C1, A2, B2, C2, C2 and 5 A3, 5 B3, 5 C3. Now I am coming to the third and final elementary row operation on a matrix. The third operation is addition of a scalar multiple of one row or column to another row or column. That is denoted by R, I, J, C or R, I plus C, R, J. That is, you are multiplying the jth row of the matrix by the non-zero scalar C, and then you are adding the elements of the jth row to the corresponding elements of the ith row. Suppose this is a matrix A1, B1, C1, A2, B2, C2 and A3, B3, C3, and I am operating on it R1, 2, 3. That is, I will multiply the second row of the matrix by the non-zero scalar 3, and then I will add the elements of the second row to the elements of the first row. A1 plus 3A2, B1 plus 3B2, C1 plus 3C2. A2, B2, C2 and A3, B3, C3. So these are the only three types of elementary operations that we apply on a matrix. When we apply it on the row on the rows of a matrix, then these operations are called elementary row operations, and when we apply it to the columns of a matrix, then these operations are called elementary column operation. So what we need to do is that we will apply these three types of elementary row operations on a matrix to transform the matrix in a row reduced echelon form, and we will find the number of non-zero rows of the matrix, and that number of non-zero rows will determine the rank of a matrix. In my next video we will find the rank of a matrix by using these three types of elementary row operations. So stay connected and go to my next video.